Okay. Good afternoon. Today, chapter 6. We're going to talk about basic SQL. This one is the next part after you design the database and create something and insert data. Actually, we have to use this kind of command to insert the data into your database. It's basic command. You have to understand what are they. Here is the outline of today. So we try to understand the data definition and data types that we can use with SQL, and then how to set up the constraints using SQL and basic retrieval queries in SQL, and also the basic command insert, delete, update statements in SQL. Okay, basically maybe about that. Okay, first the basic SQL. So SQL is the language considered one of major reasons for the commercial success of relational database. So the original SQL is relational predicate calculus called tuple calculus. If you have time, maybe you talk about that. I think we should talk about it a little. Okay, which was proposed initially as language square. SQL actually comes from the word SQL, which was original term used in the paper SQL to Square by Chamberlain and Boyce. But the company that tried to develop a database called IBM could not copyright that term. So they abbreviate to SQL or SQL. And sometimes when they sell that product, SQL, they call this product SQL. And copyright the term SQL. Now, popularly known as structured query language. Okay, sometimes you can, when you talk with IBM or Microsoft people, they call their product SQL database. Okay, from SQL. Same word, like same sound. SQL, SQL. Very interesting. Anyway, SQL data definition, data types, and standards. Okay, we have several words, terminology. The table is a relation, right? Table is relation, including rows and columns. Three terms used for relational model terms: relationship, tuple, and attribute. Table is the relation, row is tuple, column is attribute. Okay, and they have several standards that we have to know. This one, the language has feature for data definition to define the type of the data, constraint of the data, and data manipulation, insert, update, delete, or join the set of the data, or select the specific data that we want, or answer some questions. Okay, and transaction control also, indexing to speed up to search. When you want to search something, if you have 1 million rows and you don't have any index, you have to search like sequential search. It spend a lot of time. But if you have index structure like B3 or hatching, it's faster. But you need more space to contain this index. And security specification and activity database like log data, active database and multimedia and distributed database. Actually, there are a lot of technology behind the scene that you have to know when you're going to be the database admin. And also, recently we use cloud service, and we have to understand service of cloud also, and database is on top of the cloud technology. So we have to understand two layers. And actually, when you understand the cloud, maybe you can understand how to scale it up when we have more load, or set up automatically scale when you have increase the load exponential, how to set it up. So actually, when you try to develop the system that can be scaled, you have to decide at the first place that you want to separate the database and application server, and also the database structure have to support the scale up also. Okay, and the other one, create statement, is the main SQL command for data definition. Create database, create table, create view, create. Several create. You'll learn about that. Okay. And we have schema and catalog concepts in SQL. Okay. They are variations of existing DBMS, relational database management systems. Okay. And SQL schema, we have schematic that identify by schema name and include authorization identifier descriptor for each element. And also schema elements include table, constraint, view, domain, and the other construction. Anyway, let's see. Each statement in SQL ends with a semicolon. Semicolon. Let's see. Create schema statement like this one. Create schema company authorization J Smith. This is example of create schema. And catalog is named collection of schema in SQL environment. SQL also has concept of cluster of catalogs. Okay, this is just collection of schema. But the thing you have to understand more specific is create table. Okay. Oh my goodness. Sorry. Actually, before you create the table, you have to create database. But the command is very simple. Create database. After that, you can create table inside the database. So when you create database, you have to decide first, right? What kind of database you want? How many attributes inside? Which attribute is the primary key? What kind of the data type for each attribute? You have to decide everything. And also the table name. The table name. Okay. This one, create table. Specify a new relation. Provide name of the table. Attributes. Types of data inside and initial constraint. Which column can be now, cannot be now, and also the range of the domain of the data, initial value, you have default for them or not. You can have to specify everything when you create a table. Actually you can add or set it up later for more details, but in the first place you should know roughly the whole things about the table before you create a database. Okay, so here create table company dot employee. Actually, company is the name of the database, but if you are already inside the database name company, you can just use create table and the name of the table. Don't have to specify the database anymore. ได้ขี้เกียจไว้ก่อน create table any tools. Okay, create new tables. You can see that table name test 4 columns after that They don't show anything. You can just add anything you want as the column name, right? CSS325. Okay, maybe this one will show you the code, maybe preview SQL. Okay, this is like a RDBMS that support you to generate SQL command using interface, graphic user interface. You just add the detail of the database you want, the table you want, and they show you the create command, create table, and then this one they automatically add the database name for us, company DB, and I just add the table name test, and after that is the detail of each columns or attributes in the database, right? If you would add more details, the code will change. Like if I add default here as defined, and we add some value 0, and oh no, okay, and I select the second one, test2, as the key. Where is the key? Where is the key? Key. Okay, actually now index, and here primary key. Wow. Advanced option, no. And we check the code again, preview. There are a lot more detail about the option I already add. For example, for the attribute, the first attribute, I set up not now, and I also give the default for them, that is 0, so you can see the code. And also we set the test2 is not now, and primary key. Primary key. Oh, sorry, I missed some mistake. I set this one primary key, but can be now. Hey. Now. Yep, you can learn from this kind of interface. Okay, test2 not now, and primary key here, right? As you can see, we can set anything from this interface. Very simple. But anyway, you have to learn. You have to learn what does this mean, right? Or the architecture of the each company. And you can also create the virtual relation. We call them views. View. Creating through create view statement. Actually, this one just like a set of command that select the data from the original table and prepare them for just only view. Cannot change anything. Okay. Why we have to do that? Because sometimes you have a huge data in your database. Like, for example, in this university, we have students, about 40,000 students in this university, but only 50 students in my class. If I retrieve the data of students in my class from 40,000, every time you spend a lot of time to join a lot of tables, and this becomes slow because not only me use the database, right? So the database can prepare the views for this class only, and select the data from me, only this class students. And when I click to view the class, the data retrieved from the table immediately. Don't have to search for the name of student and join with the registration table, many tables. Just only the view that prepare. So it's become faster. But the problem is you have to spend more space to store the view. This trade-off. Okay. Anything else? Here, whoa, we come too fast. Whoa. Okay. And actually we use this kind of the example that you already know the structure of the company structure to show the result of the command. And here is the example of the data inside each table, like employee. We have name, middle name, last name, and SSN as the key, and birth date, address, sex, and salary. Super SSN is like a supervisor, right? And DNO, department number, as foreign key. If you can remember the structure of ER diagram, you can understand the relation between the attributes, the relation table. Okay, so we have employee table, department location, and the other one works on project and dependent. This is the example data. Okay. And when we want to create this kind of the table, this show how to create. This is create statement for the project. Project. Okay, project. As we can see here, project we have 1, 2, 3, 4 attributes, 4 columns. The first one, P name, project number, P location, department number. From requirement, we know that the project name use character, right? Just characteristic, and the P number is a number only, and this one also primary key. Okay, and P location is character, and D number is number. And also we have to know that if this one P number is the primary key, this one cannot be null, right? Cannot be null and cannot be duplicate. Just unique value only. We have to concern about that at first. We have to remember. And then we check the command. Okay, now P name, we use var 15. So the maximum character that can insert into this attribute, just only 15 characters. And of course, not now. And this one P number, integer, not now, because this one will be the primary key. And P location can be now. D number, not now, integer. And here, the primary key, we'll set the P number as the primary key, okay? And unique P name, so you cannot duplicate the name of the project. And we also identify the foreign key denum is here, denum. Reference to the other table. The table name is department. The column that we reference to is the D number. So we can see the relation between the table using this foreign key connect to the primary key of the department table. Okay. So many details, but you can add this kind of the definition later. That's fine. Oi. Decimal. Okay. And we said primary key is SSN. Anything interesting? Okay. Maybe already similar way. Set primary key, set unique, and set foreign key and reference to the primary key to the other table. Okay. Project works on an dependent table also similar way. You have to define everything before you create the table. But in ER, we don't know this kind of the data, right? We have to identify it later. But from your requirement, actually you should know that already. And if you don't know the maximum character you're going to use, you just get more requirement from your customer. And what is different between char and varchar? Var from variable. When you store the data to char 9, that means you use 9 character, even though your data just 4, but the other 5 character already used. So the space of the data store always 9 characters. When you know the length, it's quite easier to search. But about varchar, just use the space as it. If you identify maximum 15 and you use just 4 characters, when you store the data into the hard disk, you just use 4 characters. But you can vary to maximum 15 characters, that's all. But when the length of the data is changed all the time, this one is quite difficult to search because the length change. So if you choose varchar, you should add index into your database to improve the search efficiency. But you use reduce the size of the data more than use char. Okay. Basic data types. Numeric, you know that. Integer, number, integer, and int and small integer. So actually this one is we have different maximum number of the data store. For let's see, 32,768 to 32,767. So the size, range of the data is so different. And also int, okay, it's longer. When you select the data type, you have to understand the minimum and maximum number that you can store in your database. Okay. SQL data type in W3 schools. You can reference from this website. And also the other data, you don't have to select something very obvious. And character string, fixed length, use char. Okay, fixed length. And varying length when you store in your physical hard disk, using varchar or char varying or character varying, depends on, this one is like a syntax for the words, for the same object, depends on the brand of the database. And also we have bit string 0 and 1, right? 0 and 1. And we also have blob. This one is binary large object. You can store the data. And here they said 10 gigabit. Gigabit. When you want to store the image, store the video or multimedia or the other document, you can store the data using blob. And also we have boolean, date. Actually the date we have 10 positions. For example, year 4, right? 4 position, and then dash 1 dash dd, total 10 position. Here is like 4 dash 3 dash dd 3, 4 3 3, totally 10 positions. That's all. Year, month, date. And multiple mapping functions were available in RDBMS to change date format. Sometimes you combine the data from several databases, and one database use year, month, day, and the other database use day, month, year. Sometimes you use just month, year, day, I don't know, but we have some kind of the function to automatically change the format. It's very convenient when you use database. Okay, what else? Timestamps. Timestamp include date and time in one field. Okay, this one plus an minimum of 6 position for decimal fractions of second. Okay, and also time zone. We have option time zone also. Moreover, we have date, time, timestamp, and interval. Data types can be cast or convert to string format for comparison. If you have start date, end date, you can calculate the interval time between start date and end date, right? Also time. What else? Domain. You can set up your domain, specify your domain. Domain is name used with attribute specification. Makes it easier to change data types for a domain that is used by numerous attributes. Improve schema readability. For example, you define SSN type, and SSN use several places in the database, and you don't want to set up the details for this data several times. You just set up the domain SSN that character maximum length 9, and you use this domain to identify the data type. That's fine, but you have to create the domain at first. Okay, type. Use define type support for object-oriented application. Use command create type. Okay, this is option. That's fine. But domain is quite convenient for you if you have to identify more specific in details for each data, and you use that several times. Another one is basic constraints. We have 3 basic constraint types. The first one, key constraint. A primary key value cannot be duplicated. Okay, we know that. And entity integrity constraint. Okay, we have primary key value cannot be null, right? And the other one, referential integrity constraint. The foreign key must have a value that is already present as a primary key or may be null. Here is 3 basic constraints. Okay, key cannot be null, key cannot be duplicate, and reference between foreign key and primary key, right? Specify. Okay, moreover, we can set the default value. As I shown you, we can set the default if you don't want it to be null, and we can set null also if the column permit for null. If not, you just set up not null, and when you insert the data and the column that the data should not be null and no data insert into the column, the program will reject the command. So the mistake cannot be happen. And moreover, we can check. We create more details about the conditions or constraints for the table. For example, D number, department number, is integer, right? Cannot be now. And moreover, check that d number more than 0 and d number less than 21, right? So this is quite specific constraint for your business. You can add this one, check in your command when you create the table, and also restrict the number to 1 to 20. Right? Okay, so we can add a lot of details for the table command. This one is just the option when you create the table, that you have to know the data type and what kind of the data type you can use, and also the domain of the data. If you have specific domain of the data, you can set up the domain before you create the table. And when you create the table, you can use the domain that you already defined. And also we have to concern about the constraint of the table. Key can be now or not now, of course not now. And also about the duplication, when you select the column as the key, the column cannot be duplicated, right? And the other one is about referential integrity, reference to the other table. And also you can set the default for each attribute, and can set about the now and not now, and check more in detail about your conditions. For example, the range of the data domain inside the attribute. You can set it up. Okay. About the primary key. Yes, you can select the primary key using this kind of command. D number primary key. D number primary key. And unique. If you want the column value for each tuples unique, you use this one. D name, for example, D name is varchar 15 and unique. So the D name cannot be duplicated, right? Okay. And what else? Here is foreign key clause to default operation, reject, update, or violation. You have to understand when we insert the data and it will violate the referential integrity. You can set like a referential trigger action. For example, option include set now, cascade, and set default. Set now, when you, for example, if you delete the original or the primary key, you delete them, so the other reference table will be set it now, or you change the data in the primary key, and the other one reference to the primary key, right? You cascade the new data that you already update to the other tables. And set default is just set default when something change or violate the referential integrity. Action taken by the DMS for set now or set default is the same for both on delete. When you delete the original table, you can select set now or set default. And on update, two actions. And cascade, option suitable for relationship relation. What else? Using keyword constraint, name a constraint useful for later outer or. So this one is like domain. You can define the constraint, is set of constraint, and you can refer to the constraint name to use the details of the constraint. It's quite easier to manipulate or manage the constraint. Okay, this shows the example of the constraint This one is for employee table. Employee table. We have here constraint EMPPK. Oh, not easy to understand, but okay. Set the primary key. Okay, set the primary key using SSN. If the table refer to this one, so we set SSN as the key, and also if the constraint name M super something, this means the below line, 2 lines here is the details of the constraint. Foreign key, we have to set foreign key, super SSN, reference to employee SSN. And when we have action on delete of the employee, we have to set now at the super SSN. And if the employee SSN has been updated, we cascade the new one to the super SSN. This is the detail of the constraint M super foreign key, FK. And the other one also, details of each constraints. Also the condition and action, what we have to do. Okay. This is how we define the constraint and we reference them. A lot of details. But if you use the initial reference, you don't have that one. You don't have that one for reference. Correlation. Attribute index. This one is PHP my admin is embedded in SAM. Okay. Column media. Input transfer information. Okay. So now you know like an option that you can add like a unique, select a unique value, foreign key clause and other constraint, and also about the action that you going to do when we have the violate the constraint integrity, like referential integrity, what we are going to do. We can define here. So, the other one is like tuple using check. Additional constraint on individual tuples, individual rows. With in relation are also possible using check, like check and clause at the end of the create table statement. When you have the create table, right, and you can add the check in the end to like a script. Apply each tuple individually for each tuples in the table and manage starting date. For example, a manager starting date should be after department creation. This one is like you have to think about what kind of data insert and become mistake, and you have to prevent them using this kind of the command. Because manager starting date should not before the department creation. You have to create department at first, and you assign someone to be the manager of department, right? So the date should be after department creation. So the clause is just check department create date less than or equal manager start date. And also, but you don't have to add all of the conditions, okay? And also, if you think this command is too much details and difficult to manage, you can use the application you develop in the application layer to check this kind of the condition, that's fine. Like using JavaScript to check the conditions. Sometimes it's quite easier for software developer, not the database admin. But it depends on your design. Okay, but database can do that at least. Now we finish talking about the table creation. It's half of slide about just table creation and a lot of conditions and details of the data types. Okay. Next, we're talking about the select statement. When you have table, create table already, you add the data. After that, you want to retrieve the data from the tables. You should use this one, select statement. This one is one basic statement for retrieving information from database. SQL allows a table to have two or more tuples that are identical in all their attributes value. Anyway, unlike relational model. Anyway, let's see. This command, very simple. We should have select. The first thing, select. And after that, attribute list. And then from which table, where, with conditions. Just select from where. Okay. Attribute list is a list of attributes name that you want to show, you want to retrieve from the query. And table list is the list of relation names required to process the query. And the condition is a conditional, like a Boolean expression. In Boolean expression, should have like a true or false, right? And to identify tuples to be retrieved by the query. Let's see. And about the logical comparison operation, you can compare the value inside. But this one, you can compare only numeric data, okay, or date. Equal, less than equal, more than equal, and not equal. Okay, and project attribute. Project attributes mean you just list only the attributes you want to retrieve the data in the result. For if you have like a 10 attributes in your table, but you want just only 2 of them, we call this projection attributes. And the other one, selection condition, is Boolean condition that must be true. Any retrieve tuple. Let's see. For example, query 0, retrieve the birth date and address of employees whose name is John B. Smith. Okay, let's see what they want. They want information of John. What kind of information they want? They want just birth date and address. We have to back to the slide of the database of employee table. Employee table. Where is it? Employee table is here. Okay. Employee table. What they want? Data of John Smith here. What they want? Just birth date and address. Actually, the data they want is just here. So, you don't have to show the whole of the data. You just select just only 2 columns, right? Be date and address. So in your command, you have to project just 2 columns with 1 condition. 2 conditions. First name equal John and last name equal Smith. Let's see the command. Correct or not? I'm not sure. Let's see. Okay. Okay. Select. We project just only 2 columns. Birth date and address, just only 2 columns. And here from employee table with condition where first name John, middle B, and last name Smith. 3 conditions. And we use and. Okay. And the result show here. Result. This is a result of the first of the first query. 1 row, 2 columns. Next query 1. Retrieve the name and address of all employees who work for the research department. So, if you select just only address and here is the name, so the result should be include name and address, and the result is shown here. First name and last name is name, and here is address. But actually we have the other information, middle name. If you want to show, you just add it. Just add one more column, that's fine. Okay. But you have to understand that the condition is in employee table, do you have the information about the department research name or not? If we back to the database table employee, do you know the name of the department that the employee belong to? No, right? We don't have any name of the department, but we know only department number as the foreign key. If you want the name of the department, you have to refer to department table. Is employee department table, and here is research name, and you reference that the number 5 reference to how many people? 1, 2, 3, 4. Right? 4 employees belong to the research department. But when you reference that, you have to use 2 tables. The first one, employee, and the other one that you have the research is the name of the department is the department table. You have to refer to tables, employee and department table. Let's see the command. Okay. Because research, so you have to use employee and department, and the name equal research, and the number equal DNO. It's too long. The number and DNO, which one belong to which table? Let's back to see. Because they set the name of the attribute different, right? DNO belong to employee table, and the number belong to department. This one is lucky because you use different name of the attribute, so we don't get confused. But if you use similar name the program going to be confused, and you have to add more. Okay, in case if you want to be clear for the command, you should add the table name, the number in the department in front of the bigger one, department and dot and the number. Sorry. It's more clear, okay? But sometimes the column name uses similar name, so you have to use this kind of the syntax to identify the attributes from which table, okay? So. Because from this clause, okay, the number equal research, you will get the department number here is become number 5. And the number 5 will refer to the number DNO in the employee, and the program will select the employee just only who has the D number equal 5 and show in the result. So we have just 4 employees in there who has the DNO equal 5, and if you refer to the name, it's become research. That's all. But we show just only that. First name, last name, address. But I recommend you, at the first place, if you're not sure about your command, you should add more, like a DNO, for sure, to view the whole of the data, DNO, and also department name, D name, in your result, to check. After you're sure for your command, you can delete the data and use just the minimal one. But when you for debugging, you have to check your result is true or not true. At the first page, you have to show everything, like a print every line of command, right? Similar for debugging techniques. Okay. What else? Query 2. For every project located in step 4, list the project number, the controlling department number, and the department manager's last name, address, and birth date. What? Many things. At first, we have to understand what they want. At first, set forth what they want to show. Number name, the project number. Okay, project number. Controlling department number. Department manager last name. Third one. And also address, fourth one. And birth date, fifth one. Okay. Project name belongs to project number belong to what? The first thing, located. Every project location in which table? Project location, I cannot remember. Project location may be project location. Forget it. Project location. In the project table. Project location. Okay, here. Project and P location is here. Okay. And you want to know about the manager? No. They need the department number and department manager last name. Okay. So the table, that department. So we have department number, reference to the department. In the other table, here department, and each department we have the manager SSN, and we want manager last name. So we need employee table also to check the last name. Yes. And what they want? Birth date. Last name and birth date, right? So we need 1, 2, 3 tables. So we have to get the location at first. The location in the project, and then we know the department number from department, and we know the manager, who is manager from department table, and use the SSN of the manager to check the last name using employee table, and also the address and birth date from this table. So you have to know the relation, the foreign key and primary key from the relation, all of the relation in the database, and then you can understand how to get the data. Okay, just two project located in the Stafford. Okay, and the name of the manager similar, because it's from the same department number, is balance, and the other data is belong to the manager, so the data are similar. Okay, so you can know the relation and where is data come from, right? Already. The query is very complicated if you have a lot of conditions, right? But this one is the main part of the final examination. Please try to ask several questions and create the SQL command, a lot of them.